was some things I didn't find, but I'm guessing I'm seeing what.
Sure.
Yes.
Well, given that we're going to maybe share this with your colleagues as well, I'll start at the start, and hopefully we'll cover off that initial requirement that you shared via email. But yeah, so I'm John Ashley. I work for InnerView Insights. We've recently merged with LineSmart, so you would have seen a lot of information on the linesmarts.com website. That's where you came in. But the company I work for is InnerView Insights. We are now one with LineSmarts, but that was only in January this year, so it's a brand new relationship. I've been personally using the Axonic product for a couple of years now and really enjoy working with it, so that made sense for us to come together. I'll share some slides that will help bring a little bit of a picture of what we do together. Share this. I guess as well as having fjords, we also have a few mountains. This was in middle of North Island of New Zealand, where I'm based, called Mount Taranaki. And I was down visiting a customer who's using the same products. And so your question around phase separation, I actually went and measured some of their lines, and that helped explain how we would approach this. So a couple of things we do there. Axonic for overhead line measurement. And also we have a pole inspection technology, which I'll just briefly touch on because I see you guys use IML's resistograph, and I don't know how tightly bound you are to that. If it's working for you, cool. If you were looking at some other technologies, we've got something that we think is pretty special there as well. So why work with us, or why do utility and electricity companies work with us? It's really to solve the problems of safety of their network. Poles having unassisted failures is something you want to avoid, either when people are climbing them as a line mechanic or as the general public. Safety is very important. Secondly, as you're obviously aware, is the network resiliency. So how we can harden our networks and prevent against pole failures in the field, and especially cascade failures. And finally, when you compare the way we approach pole inspection, is that we have a full audit trail because we're doing everything with digital technology and tools. You can go back and say, well, who did what when, and show evidence of that transaction or that record, which I know is exactly what you guys are doing in Norway as well with your own tool set, from what I could see. But a lot of the places that we work in North America, they've got very basic paper-based processes or manual processes to gather the data, and it's scattered all around. So we like to bring all the information into one cloud-hosted database for analysis and reporting. So talking specifically about Axonic, that's our solution that is designed specifically for overhead lines. So it lets us do a whole range of things, and we sort of think about it as like a Swiss Army knife or a toolkit for line designers and field crews who are doing installs or upgrades of networks, and also asset inspectors, so people going out into the field to just measure pole condition. They might be looking at defects on a pole, or they might be looking at lean and deflection, that sort of stuff. I'm not sure, do you do much in terms of measuring joint use, or where you have maybe a line that's an electricity company owns the line or the pole, but a communications company might hang fiber or copper off those?
Yes.
Yeah. So that concept of joint use, especially in the US market, they have a 5-yearly audit, and you can see who's attached to your pole, and you can charge them a rental fee and make sure they're paying for what they've done. But also when someone comes and says, I want to put a new attachment, you can work out the additional load that would impart on the pole and say, is this pole rated correctly for additional load? So that's an important part of what it does. It's built by engineers. It does things like single pole load analysis, which you can see. I'll show you some of these slides as we go. So these 3 images are just menu and a couple of the features. So that's the mobile device. But we also have it working on a PC desktop as well. So the same user can capture field information on Android or iOS mobile, and then take that back and work on it, or communicate that back and have a team member in line design looking at your pole data in the field. We continue to do R&D and product updates. So our latest release, we put in a whole lot of features. Won't mean much to you as you weren't a previous user, but you can see we're continuing to build out, and I'll show you some of those things as we go through.
So we can do the measurements and stuff on the PC,
Correct.
not
Correct.
in the field.
Yeah.
Yes.
Both actually. So that's really good. And really the workflow looks a bit like this. You turn up. One thing that we find, and I'm interested in what your experience is, but the GIS data can be variable quality. It could be, in many examples, we see about 40% of records are incorrect when it comes to what is the conductor. So if you want to understand the load on a pole, you need to know what the physical properties of the conductors are, as well as their conductive, electrical properties. So one of the really neat features of Axonic, and actually quite importantly, something you can't do well with LiDAR, is get very accurate determination of the diameter of a conductor. So actually you'll see this image I've got another version of this zoomed in, but what I've done here is I've stood under a conductor. So I've stood at the pole, taken a photo vertically, and then using a laser rangefinder, I just measure the distance to the wire. And then it calculates with those little red bars. I move those to match the width of the pole, of the wire, and that tells me it's actually 16.11 millimeters, and then starts to give me a menu of potential conductors that are very close to that diameter. So at the moment here, it's saying it might be cricket, it might be copper. And then you can also filter that. So you can say, well, I know it's not copper, it's an aluminium conductor, so it's more likely to be an AEC or ACSR. So you can turn off that, you can turn off the PVC shielded. So it's just a way of working out what is the conductor on the pole when you're at the pole. So that's a really important feature.
One question about the distance, the laser distance. Do you use some special kind of laser distance, or how can you touch the touch the
So you can start with a very cheap golf laser rangefinder style. So that's just the same as hunting or golfing. But this is the one that we recommend. This is the engineering grade device. I don't know if that's showing the blur, but it's a True Pulse 200X. Can you see that okay? Oh, it's not showing here.
Yes. Yeah. Okay.
Yeah. So that laser rangefinder has a very precise measurement, like 4 centimeters at 1,000 meters kind of variation. It's like 10 times the quality of that one. Yeah. And so it all depends how accurate you want to get.
Yes.
So those are expensive, but they're the best that you can get. They're a US device, so it's called True Pulse. I can message you that detail. But so the distance measurement for the conductor is really important to have an accurate measurement, because you're talking about fractions of millimeters. Yes. If you're talking about pole height, pole lean, and phase separation, we actually have other ways of measuring as well. Like you can actually use a calibrated height stick, so a painted stick or a composite. We have a clip together stick that has sections, and you just lean that against the poles, and then the photo has a known height reference that we can offset as a measurement. So it's kind of like how you measure the pole is multiple options, and then everything else you can do in the app. So the workflow is you measure the conductors separately, you stand back, take what we call a multi-measurement, and then that gives you your structures, and then you measure the distance to each one of those. So you'd say, 15 meters and 85 meters, and then all of the rest of the calculations are done for you by Axonic. So it's a pretty simple thing to do. I'll run through some of these other things. I've got photos of different screens as well, that including the other one you talked about. I mentioned already it works on iOS, Android, and a PC. So in the same way as you were looking at those screenshots, you can, go to a previously captured record, zoom in, and then add new measurements. You can't obviously add a distance if you haven't been in the field and measured it. So that's a closer view of the example that we looked at the start there. And actually, as I zoomed in, the answer here was actually it was Dingo. So I confirmed that. So Dingo is 16.8 millimeters. We have a crazy name for all of our conductors over here. And, but yeah, so that is, it tells you there it's 0.04 millimeters away from being Dingo. And actually, that is the answer. So I confirmed that in the GIS, and it was all married up. Next thing is structure measurement. So poles can, as you know, lean. They can also deflect. And so if you know that pole is 11 meters long and you tell it it's an 11-meter pole, we can see, or this one here, it can see you've got 8.25 meters out of the ground. So it can work out how much is below ground. And actually, I'm only showing lean here, but it also would show if there was a deflection where that pole is bending away. This midpoint here would show, it would sort of measure how far off the center line the pole is bent. So that's important for considering what to do with the pole, or what to do with the tensions on the conductors. Do your team actually do physical work on lines, or just survey and measure?
Just the survey and measure and the rotor control. But the lean of the degrees, it's very interesting because it's like you and me can go out and feel like I can say it's too much of a lean, and you can say something else.
Yes.
But here it's kind of more of a fact.
It's a fact. It's a fact, and it also is a fact at a point in time. So you can also say, when you go back in 12 months, has that pole started to lean more? And that's a problem. Or is it stable? I talked to a guy in Ireland. He said all our poles are on the lean because they got soft, peaty ground. And so the ground is at high winds, and so their poles lean. That's not a problem if it's stable, but if it's continuing to lean, or it's unsafe angle. And so you, again, like you said, one person says it's safe, another person says it's not safe. This will tell you the fact, and you say if the limit is 10 degrees, then this one is so close to being over the limit. What do you do? So you would log a defect. They would then have to go and straighten the pole, guy, put stays on it, or replace the pole. I don't have a lot of slides on the pole analysis, but one of the main use cases for the Axonic product is for a line designer. So someone actually going to design a new network or an upgraded network. And so the question might be, what's the load on that pole with these conductors? And if I change these conductors to something heavier for more ampacity, what class of pole might I need? So you can model that in the field when you're standing at the pole using the Axonic solution. So it'll actually tell you all the vectors of the force, longitudinal, transverse, vertical, and then you can say, well, if this was a 12-meter pole with thicker butt, would it, what would its percentage capacity be? So there's tools in there that do that. This is getting more towards what you asked about, which is conductor measurements. So here we're looking at what we do is after we have the structures, we click on the attachments and we just click 3 points, attachment somewhere on this catenary and the other attachment. And it'll tell us, because we know it's dingo in this case, because we measured it with the conductor, and we know it was 17 degrees on the day I did this, which was yesterday, then it'll work out the sag from the straight line, and also it's 5.5 kilonewtons of tension on that line, which is 15% of its total capacity. So they have rules and regulations about how much of the capacity the line can be at, and you can work out whether that's within the bounds or not. And then it's quite important as well, you can do load cases, so you can work out what is it today at 17 degrees, but what would it be with ice and snow and high wind, or at 75 degrees when it's running at full capacity. So it'll change, obviously in sag, in high temperatures it'll sag lower, in strong winds it'll blow out further. So all of that is calculated inside the app. We have photo observations. Again, if you're going out measuring things, you're doing your pole top drone footage, but you might be looking and see a defect on the ground, or you just might want to look at the setting of that pole. You can capture photos and attach them as part of that asset record. So this is an example, capturing it in the field and how it might appear when you're back at the desk, and being able to cycle through 14 different photos and then the conductor measurement and the tensions and sag. You can do measurements of multiple spans at one time. So from one image I can see 4 structures or 4 poles, and it'll give me the bearing, the distance, and the turn-off angle for each of the junction points. So if you're doing something like a sharp turn, you might want to think about a heavier pole if you're a line designer, or your customers might want to think about that. So that might just be interesting stuff for them. Now you're already capturing information on your Small World mobile app, but we have one that's based on a condition assessment guide, and it has an ontology that matches. So it's a hierarchy of information that's about cross arms and then the components of a cross arm, so that later on you can do defects, condition assessments, and also you can do failure analysis. So if you broke a lot of cross arms, you could say, well, how many timber cross arms have we got where the king bolt is flogging? And then you can start to predict other poles that might have failures similar to the one you observed. Equipment height measuring is narrowing in on one of the cases that you asked about. In fact, that's one of the ways we do the phase separation stuff. So again, you've just done one measurement to the pole, so you know the distance, then all the things like the height of attachments is calculated for you. So here it is in metric and imperial. This is the one I actually did for you because you were saying that you want to look at phase separation. Is this what you were thinking of? So what is the horizontal distance on a pole between these conductors?
Yes, it's the distance. Yes, okay. So the horizontal distance,
yeah,
is down there with the 0 point. Okay.
Yeah,
and that's so in meter.
Yeah, that's in meters, and they'll be in feet if you're in the countries, US. But yeah, so we're all metric in New Zealand. But yes. So you can plot those points, and because I don't know how your conductors are set up, but in New Zealand and other countries, they sometimes will stagger the middle phase. So it'll have this separation here, but the separation will be different here. So so we've basically got multiple ways of measuring things on power poles. For what you talked about, that's probably the first way I'd start it. and you can also export that data into a CSV file, JSON file, get the image, so you'll have a multimedia. So you could say, dump it into a spreadsheet, and then you'd have to do a bit of maths to work out, if you were trying to work out the total distance, these are from the center line, so it's plus or minus, and center line of the pole. So, but I will just, because it's topical, because I was talking to the developer of the software about your case, and there is one other clever way you could do it. See, this is 40.5 millimeters. If I pulled that out to there, it might say 400 millimeters. So you can actually do that as well. In fact, I could just about show you. So that's not the official way we would do that, but we were talking about how you might do it, because the phase separation will change as you move down a line. So if I just go here to that one there, helpful if I had one that had more conductors in it. Hang on, number of conductors too. Ooh. The first one. Oh, I thought I had a photo of. And there we go. Here we go. Here. So if this, as I said, this is the feature that works out how wide is that cable, and you can see here as I do this, it's saying here it's 18 millimeters away from being goat, but I haven't correctly done that. So if I actually do this, rotate that a little bit and close it up to there. There you go. It's now saying I'm actually 1 millimeter away from goat, and that's at 27 meters high. So it's quite a big transmission tower. So that's how that feature works. But I was just thinking about as well is that if I went to this one, I'll go to this one here. If I wanted to do that, then you actually there's another way of getting an approximate phase separation. Oh, those are on different. That's not valid, that one, because they're on different circuits. But you can see what you could do if you captured it. And all of that it's all triangulated off that original distance. So yeah, so if imagine a scenario, a different pole. I'm just going to replace that to where it was, where they were actually on the same line, which I do think I have one in here. I'll do that just up here somewhere. There. Yeah, so a couple of those are attached at the same height. So I could have done that that one there. So I could say they are pretty reliably 450 mils apart, 460 mils apart. So that's not a conductor measurement, but it's using the conductor measurement way of getting a horizontal spacing. But when I explained your requirement, the other thing that the developers were saying is that we always try and enhance the product. So if there was something about that was going to be a valuable feature, which that is, then we would probably bake that in. So you'd actually end up with a, rather than it being this, it would be more of a, in the multi-measurement tool.
Yes.
We would do it through this. We'd have another feature to calculate things like that. Okay, I'll switch back to the slides and just kind of carry on with a few of those little things. So yeah, so conductor measurements, photo observations. The attachment heights is really, this was the one here with a bit more information there about it for you. So you can see here, I zoomed in, and as I mentioned, you could export that data, and you can name them different things if you had a way of identifying what phase they were. So that was the main example I wanted to show you for that. I mentioned about assessments, so you could record things like whether there's corrosion at a particular part of the pole, capture a whole bunch of photos, survey things like other poles that are in the same location. Yeah, and then probably the last interesting thing might be of use to you, and this is another way of actually also measuring distances across the pole, is we have a clearance restrictions here. Our guidelines are called New Zealand Electrical Code of Practice 34. In the US, it's NESC. I don't know what rules are applying in Norway, but you will have something about how close you can approach overhead lines, and that will change by voltage. So in our case, we plotted these survey points. We use a laser rangefinder from where we took the photo. We measure the poles. Then we say we're interested in the roof, we're interested in the balcony where someone might stand, and we're interested in these conductors. There's high voltage, 11 kilovolt, and low voltage, and it'll actually work through the scenarios, and it'll say that for the 11 kV, that conductor will be the one that gets closest when there's a high wind from 135 degrees. And when that happens, your total clearance is 3.6 meters. So that's in a straight line radial distance, which is kind of there. And it factors in conductor blowout, says that you need to be 2.1 meters away, so you will have 1.5 meters buffer. So all of that is done in the app on the spot, whereas what normally happens is that people take survey measurements, or they use a hot stick and actually go up and measure the lines with rubber gloves, which I hate the idea of, and then they take those measurements, go back to their office and do hours of calculations to work out that stuff, whereas I can just take a photo, a couple of measurements with a rangefinder, and then all of the logic and all the rules apply for me. So that's a pretty useful feature.
And so you can also do just the measurements, like with the distance there, and make the calculations on the PC.
Correct. Yeah, that's right. The simple thing there is just like clearance height. Actually, I can show you in a real example. In fact, I think I can show you that example. Or maybe not. Maybe. If I'm lucky. Yeah, that's the one. Yeah, so you can actually, after you come back to the office, I've already got this mapped. This is from a different position, it's the same building. But I can turn on this point and I say, I want to add a new one only under the center line, because I'm not there to take a laser rangefinder. But if I want to say, what is the distance to the ground at that point? And I have to say, sorry, what it is. Sorry. It's traversable ground. That's the spot that I chose. And then when I go to analysis, when I choose the clearance, it should tell me, say on the day. Where is it there? Yeah. There it is there. So on the day, that's actually 0.9 meters off the center line of that. And it is 7.6 meters vertical clearance. And it is, the only clearance required was 2 meters. So I actually have a big buffer there, 5.5 meters clearance. So you can imagine how that would be useful for the work you're doing, where you had someone say, how close is that to the building or a scaffold, or to a pedestrian walkway like this? So having gathered, all I did in the field was gather the information at the poles, and then all the rest of that stuff came later.
Yes.
So that's kind of the quick summary of what Axonic does. And I did want to just share a couple of things. So the reason we do it is so that you can basically enable communication around those poles and the conductors between teams. So it might be you guys might be doing the asset inspection, or you might be doing the design work, and somebody else might be owning the pole or doing the upgrade. And so you're able to share information in two ways with all those people. And then I have one last slide for you around our ultrasound. So one of the things, because I saw you doing work with resistograph, we have a different approach. We have a non-invasive pole inspection technology. It's called UB1000. It's ultrasound. And we have a pair of these probes. They fire ultrasound signals through a pole, and they look at the strength of that signal of the sound wave through the pole. And what happens is that decay inside the pole, either in the shell or in the heart, will deaden the signal. So it will slow down and it will reduce the energy out the other side. And so we're able to build a signature for that pole and measure at different heights. So you can see here it's being measured at ground line, but also we have our guides ready to move the probes up to a higher level. And we can then take a measurement at ground and 600 millimeters and 1200 millimeters and say, there's a pocket of decay in here or rot. The pole is good at this height. And so we could say, this pole is at risk of falling. Whereas if these are all consistent, you'd say, yep, that pole is good and solid. So yeah, I thought I'd share that with you in case it sparks any interest from the team who do the actual kind of drilling of poles with the resi. We don't put any holes. We tap the little waveguide nail in about 5 millimeters, but it just dents the pole. It doesn't even, we're not pushing any drills through. You don't have to send this device away to get calibrated. It calibrates itself in the field. So yeah.
How long from, like, if you say he put it in there, how long down or up can it ultrasound?
It's we sort of think of it as being like a 300 millimeter or 1 foot diameter cone of sound, that goes through. So what we would, and I have deleted all the slides because I thought they might not be super relevant, but if you're interested in that, I can do a whole session on UB1000. But we would, our whole premise is that you're looking at a decay cone, and that cone moves up the pole. So if there's decay in that pole, and you're 150 mil below ground, it'll be seeing that at the ground level. You'll get a poor signal. So it's kind of like think of it like that size dimension. And so we would take, steps up the pole. Usually it's 2 measurements on a pole, one at Goodwood, one at the suspect at the ground level. Most poles are snapping at ground line if they snap. And so this is really what we determine there. We've been around also, probably this company that I work for has been around just over 1 year, but we're spun off out of a company called Utility Asset Management. So they developed the technology. We licensed that from them. But our founders are the founders of the company that's really focused on the US market. And I'm focused on rest of the world, Norway, Europe, UK, Ireland, Australia, New Zealand, South America. So that I get the good job. I get to go anywhere that the poles are. So Yeah, so very quick overview. I hope that's been interesting. And if you would like to set up a demo, well, use it yourselves, I can send you a bit of a quote, and you can work out if it's going to be worth it. And then if you want to move forward, you can trial it. We can do some training online. Yeah. So, I mean, one thing that's interesting is how many users do you think would want to use Axonic with those sort of measurement features?
In the start, it would probably only be me and one other, so
Yeah,
like two.
Yep.
But we have more who works with rot control.
Yeah.
But we're kind of in the start with doing this kind of stuff. So
Yeah.
we don't know yet. It can be more too.
Yeah. I guess you've got
But
to know that your customers want it as well, right? So
yes,
yeah.
that's
Is
it.
there anything that I mean, I'll send you a pricing for 2 users. If you're happy, I
Yes.
think we could train you, we could train you over Teams. I can use the device on a mobile in real time, join a Teams call and share that, and you could have it on your device and play along. So I think we could avoid, travel to do the rollout if it's just 2 people, and you're already familiar with technology. So I'll flick you through that. If you're interested in that, I can set you up a trial demo.
Yes.
There is a version you can download now from the App Store, but the problem is it won't have the ability to save anything. So everything is
Yes.
just like you'll do a measurement and then it'll,
It's
it'll
for
tell you
testing.
something. Yeah, correct.
Kind
So
of, yes.
cool. Is there
But
anything else that either sparked interest or you had any questions about?
no, you covered everything that I was going to ask for, and we're just a quote for what it's cost per user, and stuff would be good.
Awesome.
Yes.
Excellent. Well, great to meet you. And yeah, I was fascinated when I saw your website. It looks like a really cool place to work.
Yes.
I did my degree in GIS, and so every time I sort of see people who are doing similar things, I'm always really interested in that. Yeah, so great to meet you, and I'll flick you through a email probably later on tomorrow, and then I'm traveling to the US next week, but it's available on email or calls if you need to catch up
Yes.
and have follow-up meetings.
Yes. Sounds great.
Awesome.
I'll hear from you.
Awesome. Have a great day.
Awesome.
Bye.
Have a great day.